All right, guys, in this lesson, we're going to talk about properties of rectangles, rhombuses, and squares, right? So we've talked about the properties of parallelograms here so far, and we're going to look at, seeing what these different figures have in common, and then what are the differences that are going to make rectangles, rhombuses, and squares special, okay, or unique. All right, so we're going to review sort of what the properties of parallelograms are 2 or 3 times in this lesson, right? And then talk about how rectangles and rhombuses and squares are just a little bit different. Okay, so kind of put it like a star next to this one or highlight this one, right? So if any parallelogram is equiangular, okay, we're going to call it a rectangle. Okay, now there's going to be a few other little things that are different with that, so just go ahead and follow along and mark these diagrams as we go so that you guys have a good thing to look back on. Right, so a rectangle follows all the same criteria of a parallelogram, but it also has some additional properties. Okay, so let's review sort of what a parallelogram has, right, as well as a rectangle. All right, so a parallelogram is going to have the opposite sides that are congruent. Okay, so how do we mark that? Well, we can do it like this. Okay, so opposite sides that are congruent. Okay, easy enough. All right, we also have the opposite angles that are congruent. Okay, so we would maybe say something like this. Right, and then something like this. Okay, so that's again a property of a parallelogram that a rectangle also has. Okay, all right, so let's look at now consecutive angles that are supplementary. Okay, so there's a couple ways. If we look at it through this angle right here, okay, consecutive basically meaning in a row. So if I added these 2 angles together, they would be supplementary, or they would add to 180 degrees. Okay, that would also happen if I added like these 2 angles together, right? Together, those 2 angles, right, their sum would be 180 degrees. Okay, so that wasn't really covered maybe totally explicitly in the last lesson, so just wanted to be sure that I pointed that out as well. Okay, the next one, right, opposite sides that are parallel. Okay, so opposite sides that are parallel, we can mark it like this. Okay, those sides are parallel, and these sides are parallel. Okay, so we just kind of put those little arrows on there. Okay, that is also a property of a parallelogram. Okay, and then finally the last one, the diagonals bisect each other. So I'm going to grab a line tool here. Again, diagonals just go to segment from one vertex to a non-consecutive vertex. So we've used quite a few markings here already, so I guess I can just use sort of like 3 and 4. So let me see what color. I've used all the colors so far, but well, let's see, I'll just go ahead and use red again. So diagonals bisecting each other, if I put 3 tick marks on here, it's just going to show that those 2 segments are congruent. Okay, and I'll even do like 4 tick marks on each of these. Okay, so those are the properties of parallelograms, right, that are also going to apply to rectangles, right? But as we kind of scroll up here, right, what makes this a special parallelogram? Right? What other things make a rectangle unique that isn't necessarily true or isn't true for a normal parallelogram? Okay, well, to me, these first 2 kind of go hand in hand. Okay, rectangles are equiangular and there are all right angles. Okay, so all of the angles are the same and they're all 90 degrees. So you can go ahead and mark that. Okay, and then the other thing that is going to make these rectangles unique is that the diagonals are congruent. Okay, so I'm going to go ahead and mark this, or I'll kind of write out these diagonals here with, let's maybe use a different color. I don't know, purple is fine. Okay, I'll go ahead and kind of just draw these diagonals here. Okay, and then how do we show that these are congruent? Okay, I'm just going to use 1 tick mark for each of these little segments. So they still bisect each other, right? But it just so happens that these diagonals also are going to have the exact same measure. Okay, so these are really the only ways, right, that a rectangle is unique or just a little bit different from a parallelogram. It has all the properties of a parallelogram and a few things in addition. Okay, so we can use this to solve a pretty simple problem here. So let's take a look at this one. So it says if AC equals 14x plus 17 and BD equals 68 minus 3x, then what value of x makes this a rectangle? Okay, well, they're referring to AC here, right, and BD here. So they are referring to the diagonals in this problem, right? So all we really got to do is set up an equation and solve it. So we're going to say that these diagonals are congruent, so AC must be equal to BD. Okay, we will substitute in the values in terms of x. So AC is 14x plus 17. Okay, and that BD is 68 minus 3x. Okay, a little bit of algebra here. If I add 3x to each side, I'd have 17x. If And if I subtract that positive 17 to both sides, so subtract 17, what I end up here is 51. Okay, and if I divide, I would end up getting now that x equals 3. So that is the value of x that would make this parallelogram or make this quadrilateral a rectangle. Okay, so let's go ahead and start looking at some different figures that are going to be, you know, kind of have all these properties of a parallelogram, but then have some other things as well. Okay, so we're going to review this again, right? So again, if a parallelogram is equilateral, right, this is the thing you can kind of highlight or put stars next to or something, right? But if a parallelogram is equilateral, okay, meaning that all sides have the same measure, or all segments have the same measure, then we're going to call it a rhombus. Okay, so a rhombus follows all the criteria of a parallelogram, and it has some additional properties. Okay, so like a parallelogram, all these things are still true, right? And let's review them. Okay, for a parallelogram, opposite sides are congruent. Boom. Okay, the opposite angles are congruent. We've done this already as well. So here's the opposite angles. There's one arc mark on those opposite angles. Here are two arc marks on the opposite angles. Okay, the next one, consecutive angles are supplementary, right? So any two angles in a row without skipping one, if you add them up, their sum is 180 degrees. Okay, opposite sides are parallel. Okay, just parallelograms are going to have this property all the time. Okay, so I'll go ahead and mark those with those arrows to show that. And then finally, those diagonals must bisect each other, right? So I'll go ahead and put one here, there's a diagonal, here's the other diagonal, okay, and I'll just use these little markings right here to just sort of show that 1, 2, 3, 1, 2, 3. So again, if this is the point, that's going to be the midpoint or the bisector there. Okay, and I'll do 4 tick marks on this one and this one. Right, so those are just reminders of, you know, what are the properties of a parallelogram. Now, what makes the rhombus special, right? What makes it unique? Okay, well, here's the checklist, right? They're also equilateral. Okay, so equilateral meaning all of the sides have the same measure. Okay, the diagonals are perpendicular bisectors of each other. All right, we got some fancy words going on. Diagonals are perpendicular bisectors of each other, right? So perpendicular meaning 90-degree angles. So I'm going to go ahead and draw our diagonals. Okay, so here we go. Okay, let's talk about the perpendicular part first. That means that these are 90-degree angles. So I'm going to put a box in the corner there. Okay, bisectors meaning that these two have the same, these two segments have the same measure, and these two segments are going to have the same measure. Okay, now the final thing, okay, which is just kind of a cool thing because we're coming off of triangle congruence not too long ago, is that the diagonals divide the equilateral, excuse me, they divide the quadrilateral into 4 congruent triangles, right? So if we look at all of these, we could prove any of these triangles congruent. Okay, and how would we do it? Well, we would use side angle side in this case, right? Again, it looks like we have 2 sides in the included angle, so that's how we could go ahead and prove that. Okay, so again, what we just talked about here on the right-hand side was how a rhombus is unique, how it's different than a normal parallelogram. It has all of the properties of a parallelogram and some other properties. All right, so let's go ahead and look at an application problem here. Okay, so it says that you know, we have AB equals 19 minus 2x, BC equals 3x minus 16, and AE equals x minus 3. So if ABCD is a rhombus, then what is the length of BE? Okay, well, let's go ahead and get started here. So let's just kind of mark these lengths down, right? So let's go ahead and just kind of update our diagram as I say it. So we're going to call this 19 minus 2x. I'll go ahead and write it on that segment there. Okay, BC is 3x minus 16. Okay, so I'll write that over here. 3x minus 16, kind of smushing it in there, guys. Sorry about that. And then AE is x minus 3. Okay. All right. Well, if this is a rhombus, then what is the length of BE? So if it's a rhombus, we're assuming that these two side lengths have the same measure, right? That's one of the properties. Okay. So I'm going to go ahead and make an equation that pretty much just says that AB is going to be equal to BC Let's go ahead and plug in the lengths that are in terms of x. So I have now 19 minus 2x, okay, is going to be equal to, BC is 3x minus 16. Okay, and we'll go ahead and do our algebra here. Okay, so if I add, if I go ahead and add 2x to each side, what I'm going to get here is 5x. And if I add 16 to both sides, I'm going to get 35. Okay, so if I divide both sides by 5, I find out that x is 7. Okay, so that's 7. So what does that mean for us? Well, that means we can find out some of these other side lengths. Okay, so if I put this as now 19 minus 2 times 7, that's the same thing as 19 minus 14, okay, which is the same as 5. Okay, so that is 5, okay, which means that this side length is 5, okay, and that means that all of the segments on the perimeter of the rhombus are 5, right? So this would be 3 times 7, okay, minus 16, okay, if you want to write it out, you can, right? So 3 times 7 is 21, okay, and 21 minus 16 is also going to give you a side length of 5. Okay, so all of these segments are 5. Okay, not that we have to put these ones out for DC and AD, but I'll just put it there anyways. Okay, now let's kind of look back and sort of revisit what are they asking us? Okay, well, they're asking us for the length of BE. So I'm just going to sort of highlight that. Okay, they're asking us for this. Okay, and we got to think, okay, well, what would be helpful? Okay, what do we know? Okay, well, we know the length of AB is 5. The length of AE, which I failed to write down, but I'll go ahead and write it in blue. Okay, this is going to be the same as 7 minus 3, because the value of x is 7, right? So the value of AE here is actually going to be 4. Okay, so obviously my diagram here is getting a little bit busy. Okay, there's just kind of a lot going on, right, in the diagram. So what I'm going to do is simplify the diagram. But remember, if this is a rhombus, that means that this is a perpendicular. Okay, that these two segments are perpendicular, right? Meaning that it's a right angle. Okay, so I'm going to go ahead and sort of make a new picture here. So I'm just going to sort of draw. What I'm going to do here, guys, just to be clear, is I'm going to draw this triangle. Okay, and I know that's not a perfect picture there, but I'm going to draw this triangle on the side. All right, and I'll do the best I can here to make this neat. Okay, it's not going to be perfect, but basically what I just drew there was A, E, B. Okay, and what I have here is I have a right triangle with a side length of 4 and a side length of 5. Okay, and what they're asking for is they're asking for BE. So what I can use here is the Pythagorean theorem, okay, or a squared plus b squared equals c squared, right? If this is side length A, lowercase a, and this is b, and the hypotenuse is c. So I'll fill this out, right, and just say if a squared plus b squared equals c squared, okay, that means that we have 4 squared plus b squared equals c squared, or 5 squared. We end up getting now 16 plus b squared equals 25. If I subtract 16 from both sides, I get that b squared equals 9. And if I take the square root of both sides, I find out that the unknown length there is 3. So to answer our question, what is the length of BE? BE equals 3. Okay, so I'm just using the properties of a rhombus and the Pythagorean theorem to come up with our answer. Okay, so the last thing we have to talk about, right, we've talked about the differences between a rectangle and a parallelogram, and then the differences between a rhombus and a parallelogram. The last one we're going to talk about is a square, right? And there's kind of a lot to talk about in this one. There's a lot going on. So let's take a look, right? So it says if a parallelogram, and this is something you should highlight and read carefully, if a parallelogram is equiangular and equilateral, then it is a square. Okay, so squares, they follow all the criteria of a parallelogram and a rectangle and a rhombus, okay? And it has some additional properties, okay? So a square has lots and lots and lots of properties going on. Okay, so let's kind of fill this thing out. Okay, so like a parallelogram, a square has opposite sides that are congruent. Okay, good to know. Okay, this is going to be the third time we fill this out, and that's okay. Okay, the repetition is going to help in this case. Opposite angles that are congruent. Okie dokie. So we got this and this. Okay, consecutive angles that are supplementary. So again, adding any two consecutive angles, if you add them up, they're going to equal 180 degrees. Okay, opposite sides that are parallel. Okay, that's going to be true of a parallelogram, so it's going to be true of a square as well. And then finally, diagonals that bisect each other. Right, so we've done this now. This is the third time we've done this, but again, I believe the repetition in this case is going to be kind of helpful. So, so what I'll put here now is 1, 2, 3 tick marks on those two, and I'll put 4 on these ones. Okay, so again, properties that we've been through now 3 times. Now, like a rectangle, a square is equiangular. Okay, and all right angles. Again, for me, these two kind of go hand in hand. Okay, but they are equiangular. So here are my 4 right angles. Okay, and the diagonals are congruent. So if I show that again, okay, in this particular case, I'm just going to put 1 tick mark on each of these little segments, showing that they bisect each other and that they're going to have the same measure. Okay, and like a rhombus, okay, like a rhombus, a square is equilateral. So it's going to have all the side lengths are the same. Okay, the diagonals are perpendicular bisectors of each other. Okay, so if I draw the diagonals here, okay, these are perpendicular bisectors of each other. Okay, and again, the diagonals divide the quadrilateral into 4 congruent triangles. Okay, so the 4 congruent triangles here, again, you can see them pretty easily. Okay, but all of these triangles are going to be congruent by our shortcut of side angle side. Okay, now, how is this square unique? How is it special? Okay, it's a regular quadrilateral. Okay, well, what does regular mean? Okay, that means it's both equiangular. Sorry about the handwriting there on that one, but that says equiangular and it's equilateral. Okay, so how do we write that? Well, okay, here's the equiangular part. Okay, and it's equilateral, so there we go. Okay, the 4 diagonals, or the diagonals make 4 congruent isosceles triangles. Okay, so here we go. So the diagonals are going to be congruent. Okay, and perpendicular bisectors of each other. Okay, so here's how I'll mark that. Let's go, maybe I'll use blue for this one. Okay, so here's the perpendicular part. Here's the isosceles part. Okay, and again, these are congruent triangles, right? We could put side angle side again. Okay, so again, like the square has all of these properties, right? That of a parallelogram, and a lot of the properties, all the properties of a rhombus, okay, and all the properties of a rectangle, and it has some additional things, right? So this is actually pretty good. I don't think this is printed in your notes, or at least not the ones that I have. So, but this is actually a pretty good Venn diagram that just shows all of these properties, right? So, the square, you can see it's very much on the very inside of the quadrilateral, which means it's basically has all the properties of all of these things, okay, and some additional ones, okay. So let's go ahead and look at a couple of these problems here really quick and apply. Let's see, in your notes, I can see the ones that are printed. I'm just going to change a couple of values here real quick, just so that we don't get confused. And so this angle right here, we're going to go ahead and call this 2x squared minus 8. Okay, and then this value right here, I believe this is supposed to say 9x plus 4. So again, my apologies there, but please make sure that you update your notes on that. And it just tells us, you know, use this rhombus to find each measure. All right, so if this is a rhombus, okay, well, those two side lengths should be the same. Okay, so I'm going to go ahead and set 6m minus 12 equal to 4m plus 4, and I'll solve that equation. Okay, so subtracting 4m from each side, looks like I get 2m. Adding 12 to both sides, it looks like I'll get 16, and I'll get m equals 8. Okay, so if I plug 8 back in to, let's say, VW, okay, VW now will be 6 times 8 minus 12. Okay, so 6 times, that would be 48, right? So 48 minus 12, okay, and we're going to end up getting 36 there. All right, so VW is going to be equal to 36. Okay, well, that should be the same as WX. Okay, WX should get the same value there because this is a rhombus, so WX is also going to be 36. Okay, probably, you know, encourage you guys to make sure that you go back and check that, right? Is 4 times 8 plus 4, right? Is that 36? And in this case, it certainly is. Okay, so here's the other thing. Okay, all right, so if this is a rhombus, that means that this is a 90-degree angle, right? And it's giving us this in terms of x, right? So 2x squared minus 8. So I would write this out as 2x squared minus 8 is going to be equal to 90 degrees. So if I add 8 to both sides, this is Algebra 1 review now. If I add 8 to both sides, I get 2x squared equals 98. Okay, dividing by 2, I would get x squared is going to be equal to 49. Okay, and taking the square root of both sides and then using the positive value only, I would get that x equals 7. Okay, so because x equals 7 there, I can go ahead and plug in 7 here, right? So we're looking for that unknown value, or I guess we're looking for the measure of angle WVZ. Okay, that's going to be equal to 9 times 7 plus 4, right? It's going to be 63 plus 4, or the measure of angle WVZ is going to be 67 degrees. Okay, looks like we have just one last problem to get through here. Again, we're just using these properties to apply and to figure out unknown side lengths, or in this case, they're asking for the perimeter of this quadrilateral. Right, so let's mark up our diagram. Right, so this is WS, and so this is just a parallelogram, right? So WS is x plus 5, so I can mark that down. WV is x plus 9. Okay, and then VT is 2x plus 1. Okay, so, you know, not to speed through this or anything, right? But parallelograms, right, their opposite sides are going to be congruent, right? So we can set those to, you know, equal to each other. And to be neat, I'll just say, you know, WS is going to be equal to VT, or x plus 5 is going to be equal to 2x plus 1. Okay, solving or subtracting x from both sides, I'll get x on the right side and I'll get 4 on the left side. Right, and then substituting that back in, this value, right, 4 plus 5, I would find that this side length here is 9, right, which means that this opposite side should be 9 as well, and you can check your math on that, right, 2 times 4 plus 1 is 9, right. Then when I plug in, you know, 4 for x up here, right, I'll plug it in up here as well, right, so it says x plus 9 over here, right, so I'll plug in 4. Okay, and if I plug in 4 plus 9, I'm going to end up getting 13. Okay, so I get 13 there. Okay, and now that means I should get 13 here. Okay, so if I add all these guys up together, that should give me the perimeter. Okay, the perimeter for this figure, right? So a couple of 9s there would give me 18. Okay, a couple of 13s here would give me 26. Okay, and you know, feel free to use a calculator to get your answer here, but I think we get a perimeter of 44 there. Okay, so to answer the question, the perimeter is you know, 44. It doesn't give us units, so I'll just write out units. Okay, so again, you can kind of go back and check your work and make sure that everything is good there. I think you know, my value of x makes sense, and we should be able to should be able to get the right answers, guys. So go ahead and get started on your homework assignment, and we'll see you next time.